Guys, welcome back. This is Savannah from Savvy in Space, and today I thought I would talk about black holes, just sort of the basics and a little introduction to them, as well as doing sort of a black hole inspired makeup look. So we're going to be doing a dark, black, blue, smoky eye, and I think it'll be fun. Yeah. Alright, so let me go ahead and jump right in. I'm going to start by priming my face, like always, with the same e.l.f. Putty primer in the luminous finish. So, here's the thing about black holes. I know most of you probably already know this, but black holes, they are one of the most, the most extreme objects in the entire universe. They are points in space-time. So, in astronomy and cosmology, we refer to space-time as kind of what it says, a combination of the fabric of space as well as time as a fourth dimension in which things can move, right? So black holes are points in space-time where the density, that is how tightly packed the matter is in space, right? Think about density like a sponge is less dense because it's got a lot of holes in it, right? And you can squish it down, but something like a brick is really dense, right? So black holes have infinite density. That means they have, and it's because they technically have zero size. Yes, you heard me right. They're not one-dimensional, they're not a line, they're certainly not three-dimensional. They are zero-dimensional. Zero-dimensional is what we call a point. They're simply a point in space. So, I'm just taking my Juvia's Place foundation, the I Am Magic foundation in the shade 730 Isla, and mixing that about equal parts with my Wet n Wild Dewy Finish Photo Focus foundation. I'm mixing that in the back of my hand. I'm going with quite a heavy foundation today because I am doing such a heavy eye look. Alright, so like I was saying, black holes are regions in space where the density is infinite. Now, density is defined as the total mass divided by the total volume of space. So if they have some non-zero mass, they have some mass, and they have exactly zero size, well, you can kind of consider, well, it's one thing to, if you take a number of mass, let's just say, I don't know, 5 kilograms, and you divide it by 0, because they have zero volume, they don't enclose anything technically, well, technically you get an error, right? We're not allowed to divide by 0. So some people, we say they've got infinite density since they really couldn't get any denser. However, for those of you familiar with some mathematics, when you divide by 0, you don't get 0, you don't get infinity, you get broken. You get undefined, you get non-existent, you get essentially just error. If you guys want, you can try it on your calculator, just hit any number divided by 0, and you'll see that you just can't do it. So already off the bat, the most basic property of black holes, like the mass and the space that they take up, already leads us at our calculator giving us an error. I think that's pretty crazy. So there are points in space-time that are defined as having infinite density, which again is insane. Now, black holes, they have they have so much gravity. The pull of gravity around them is so strong that not even light can escape. That's why they're called black holes, because literally you cannot reflect light off the surface, because the light itself, these photons, get accreted onto the black hole. Now, that word accrete, that is a fancy astrophysicist way of saying sucked in or thrown onto. So when we say a black hole is accreting matter, that means that the black hole essentially is sucking in stuff. It's got this boundary called the Schwarzschild radius, where once you get past that point, there's no coming back. There's no coming back. It's actually also defined as the minimum radius an object would have to have of a certain mass in order to become a black hole. So that's the thing too, is like it doesn't just take like something supermassive like a dying star in order to become a black hole. If I if I squished myself into a 0 size point of volume, I could become a black hole. And that radius is defined at like the size that I would have to be squished into to become a black hole is called the Schwarzschild radius. I'm going to take my Wet n Wild Color Icon bronzer. It's like the gel bronzers in the shade Sunset Striptease. Kind of a weird name. And I'm just going to be bronzing on my face. Again, I'm going to bronze pretty heavily just to sort of balance out the heavy eye makeup I'm going to be putting on. So black holes were first postulated in the early 1900s by that same guy named Schwarzschild. And he came up with the idea because when he was solving some solutions to Einstein's equations, he arrived at a theoretical possibility for there to be an object with finite mass, so with some mass, that occupies exactly 0 volume. And it wasn't until I think about 1958 that it was taken seriously and actually considered an astronomical object that we can study. Nowadays, we study black holes all the time. In fact, a lot of you have probably seen that picture from the Event Horizon Telescope, the EHT, that came out on in April of 2019. That first picture of a black hole, that's so cool. That's in a very nearby galaxy that we're able to study pretty well. I think that's probably good on bronzer. Yeah, I think so. Next I'm going to go in with the same blush I've been using for a long time now in my Natasha Denona Daria palette. I'm just going to be using the center blush shade here. And I'm going to be lightly blushing up my cheeks. Now, in our current research, we know of at least 2 types, and there's some debate on whether there's a third, different types of black holes. The 2 main categories are called solar mass black holes and supermassive black holes. Now, as someone who studies extragalactic astronomy, I focus mostly on supermassive black holes. Supermassive black holes are the kind of black holes that you're going to find at the center of every galaxy. In fact, it is postulated, though not conclusively proven, that there is a supermassive black hole at the center of every single galaxy. And we do know for sure that there is a supermassive black hole in the galaxy that we live in, the Milky Way. Its name is Sagittarius A star. Now, these black holes have masses on the order of 1 million suns. So 1 million suns would be the same mass as a typical supermassive black hole. I believe the largest one ever found was on the order of 10 billion suns. Isn't that crazy? All right, what next? Oh, let's go ahead and prime my eyes. I'm going to use my Milani eyeshadow primer. This stuff is so good. It really acts like a nice glue for your eyeshadow. Now, the other type of black hole that we study are called solar mass black holes. These are black holes that have masses on the order of 1 sun. So in astronomy, we like to use our sun as a base unit for a lot of different things. In particular, we like to use it as a mass example. So we like to say, like, solar mass black holes are on the order of, instead of measuring in kilograms, we measure in terms of how many suns it would take to make the same amount of mass. So solar mass black holes usually have about 10 to 50 solar masses in them. And that is the kind of black hole that we are able to detect the gravitational waves. Now, I'm going to scooch you guys closer in, and for my eye look, I'm going to be using the Smoke Show palette by ColourPop, and I'm also going to be using the Blue Moon palette by ColourPop, as well as the Fame palette by ColourPop. You guessed it, I really like ColourPop. Alright, let me scooch you guys in and we'll get started. Alright guys, can you see me? Alright, cool. Now I'm going to start off with a pretty plain transition shade from the ColourPop Fame palette. I'm just going to take the shade here, what's it called? Clubhouse. It's just a cool tone, sort of taupey shade. I think I'd throw it in the crease just to give it some base, some layering. You know the drill. And I'm just taking a very simple tapered blending brush in order to do this. Right. So, like I was saying, stellar mass black holes are actually more well studied since we are able to observe them with gravitational waves, which is going to be a topic of another video, don't worry. Now, the big question is, where do these black holes come from? And that's a really interesting question. For solar mass black holes, we actually do know where they come from. We know they come from massive stars, very massive stars, on the order of tens of solar masses. So a star that is living out its life, it's starting to die, and it's already about 10 times as massive as our sun. And those are going to be the black holes, or excuse me, the stars that are what we call progenitors to black holes. Those are the stars that when they die and when they collapse, they form black holes. Ooh, almost dropped my mirror. Oh, wrong palette. I'm going to be taking now, I'm going to do sort of like a halo eye, right? So I'm going to be taking the shade Slated from my ColourPop Smoke Show palette, and I'm going to be putting that through my crease a little bit, but also on the inner and outer portions to start to develop some depth. Just using my color switch here. What brush wait, no, I want a different brush. Dum-ba-dum. Yeah, that'll be good. So yeah, stellar mass black holes occur when a massive star dies. Now when stars die, what they do is they shed their outer layers first, and then they collapse under their own gravitational weight. And when a star of a certain mass, a certain minimum mass, which is about 10 solar masses, when those die, they form black holes, and those are stellar mass black holes. So we know where those come from. Unfortunately, what we don't know is where supermassive black holes come from. Honestly, we have no idea. We have no idea. We know that they're in the center of every single galaxy. And by no idea, I mean we're studying it, but we really don't know. We know that they're at the center of every galaxy. We've observed them, but we don't know where they come from because no star could possibly be massive enough in order to, when it dies, in order for the stellar remnant to be a black hole. And that's one reason why we study what we call galactic evolution, is because we want to study the the sucking in essentially of mass that the black hole does. And we want to see the relationship between the way that the galaxy evolves over time with the way the black hole grows. So we don't know where supermassive black holes come from. It's really weird. All right, I'm taking now just this black shade from the ColourPop palette, Let's Do It, and I'm putting that even more on the inner part of my eyelid and the outer part of my eyelid. It's not picking up very well. And I'm just gonna run it through the crease a little bit, sort of meet it up in the middle. I hope you guys can see. It's always hard to tell. All right, how does that look? Looks probably pretty good. Okay, I'm gonna go quickly and I'm going to go cut my eye with That always sounds so harsh. I'm gonna go put some concealer down right in the center of my lid so I can pack on a nice blue shimmer shade. All right. Alright guys, so I went and I cut my lid with a little bit of concealer. I just used the Tarte Shape Tape. I find that to be one of the most opaque concealers that I own, so I found it really, really, really good for cutting the crease. Alright, now comes the tricky part for me. I'm going to take a ColourPop shadow in from the Blue Moon palette called, let's see, what's the name? Mad About You. I'm going to take that and I'm going to pop it all over where I cut my crease. Oh, and yeah, I'm just going to take my finger. I always do this for my lid shades. I'll probably have to go in and refine it with a brush, but you know. So I think I left off talking about stellar mass black holes versus supermassive black holes. And that's actually something that I study, is supermassive black holes. What I do with my research advisor at my home university is I look at actually something more specifically called AGN, which stands for Active Galactic Nucleus. And an active black hole is different from what we call a quiet black hole. Now, what that means is that an active black hole is currently in an environment where it has enough mass around it to really being accreting a lot. And one thing that happens that people don't really realize is, yes, black holes are black, so they suck in all the light. But around the black hole is something called the corona, and the event horizon, and what's called the accretion disk. Now, when matter falls into a black hole, it swirls around it for a while before finally falling in. And when it's swirling around, it actually gets really, really hot by all the dynamical friction that's going on. So it gets really, really bright, and it gets really hot and it gets really bright, and what it does is it emits X-rays, which are really, really high energy photons. And that's one way we can detect black holes, is by looking for sources of X-rays in the center of galaxies, because that's a pretty good indicator that there's a currently accreting black hole in the center. Alright, I'm pretty happy with the way that came out. I'm going to go back into my Smoke Show palette and blend out sort of the edges where the blue shadow meets the gray and black. What brush do I want to use for that? Okay. Now, to be considered an active black hole, you actually have to be a certain amount of luminous. You have to be accreting enough mass to have an accretion disk that lights up at a certain brightness. And so there's a limit for like how bright you have to be considered active. This is tricky. It looks kind of crazy now, but I promise this is going to come together. Alright, that looks fine. So, one thing that's kind of, that confused me at first was the difference. Oh, I'm going into my Melt Muerte palette, and I'm going to take this gorgeous dark blue shimmer here, what's it called? Katrina. And I'm going to put this over where I just put that base blue down. This one has a lot of very multi-dimensional sparkle, so I really wanted that to be the lid shade, but it needs a little bit of a blue base because I wanted it to be a blue smoky eye, you know? And just going in with my finger again. Oh, that's pretty. Now, quiet black holes, this is one thing that confused me for a while. They are still accreting. They are still pulling in mass. They just aren't doing it as fast as active black holes. Oh, and by the way, the black hole at the center of our galaxy is not active. thank goodness. If it was, there'd be too much scary radiation that could actually inhibit life on Earth. So we're very glad that our Milky Way black hole Sagittarius A star is not active. All right, I like the way that's looking. I'm gonna have to go back and blend out around the edges some more, but I like the way that's looking. Now, finally, on the lid, I'm gonna go in with a shade from the ColourPop Blue Moon palette. I'm gonna take the shade Lumi here, and I'm gonna pop it right in the center pretty lightly, just to give it a little bit more dimension. All right, I'm gonna go off camera now, and I'm going to finish up my eye, do the other eye, and then when I come back, we will finish up the face, and I'll talk a little bit about how we observe black holes. All right. All right, guys, I'm back. I finished off my eyes on the lower lash line. I just smudged some of the same colors that I put in my crease down there. I put in a little bit of a liner just in the center. I don't know if you guys can see, but I didn't put it all the way across my waterline because I wanted it to amplify sort of the halo effect, you know. Now I'm going to do my lips. I'm going to use this ColourPop lip liner called Ellery. And I wanted to do a dark lip too because, I mean, I'm talking about black holes. You know, I'm going to have things be dark. That's just how it is. All right. Oh, man, it's going to be hard to talk while putting on lip liner. You guys, I'm still getting used to this whole process. If you've made it this far, leave a star emoji in the comments. Is there a star emoji? I don't know. All right. Again, perfect. Just gonna leave the lips like this. So, I was going to talk about how black holes are detected / observed, and the way that this is done. Oh, I'm going to go in with my Kat Von D cream studded kiss lipstick in Homegirl. Love this one. See, it's just, I mean, it's just a gorgeous dark reddy purple kind of color. So the way that we observe black holes is not directly, right? Obviously, black holes themselves don't emit any light. That's kind of like the black part of them, right? What we do is we observe the infalling mass in the way that it lights up. So we can detect the accretion disk around black holes in many different wavelengths. How does that look? Does that look good? Yeah, I think so. Ooh, I like that. See? We're super black hole. We're very dark, very vampy, very her, you know? So, like I was saying, we can observe black holes in all the different wavelengths, really, of the electromagnetic spectrum. We can look at them in radio, we can look at them in X-ray, we can look at them in optical. My favorite, of course, is going to be looking at them in radio. However, what I do find interesting, and this is a correlation that I hope to talk about some more in the future, is a lot of really energetic processes actually look the same when we view them in X-rays or if we view them in radio. So that's one way we can confirm if the presence of a black hole or the presence of an active black hole is by checking to see how the radio images compare to the X-ray images. What else? What else? Oh! And the way we observe the mass of a black hole, like especially the one that we have at the center of our Milky Way, is we look at the set of stars that are right directly around the black hole. And we look at the way that they move. We look at their orbits. So we can't see what they're orbiting, but we can see the shape of their orbits and the speed of their orbits. And from that, and by how fast the stars are moving around the black hole and by their exact positions, now this is called how do I say this word? Astrometry. There we go. Which means like the measurement of sizes and of speeds of objects. So we use something called stellar astrometry to detect the mass and relative size of black holes. And there's actually some really cool animations. I'll see if I can find one to put in the links down below. Of the way of how the stars at the center of our galaxy, how they orbit our black hole. It's pretty cool. All right, what's left? Oh, highlight. So I don't know how you guys feel about this look. It's not my favorite thing I've done, but I certainly don't mind it. Where's the highlighter brush? There we go. I don't mind it, but it's not my favorite. I'm going with my Natasha Denona palette, just taking some of the powder highlight. Yeah, not my favorite. We didn't get the perfect blend, but I mean, how are you supposed to, like, when you blend, right, part of what you're doing is trying to make it look natural, like it blends right into your skin, and just like dark blues and blacks and grays aren't going to blend into your skin. So I feel okay with it. I do like the way the lid shade looks, though. I think that's quite pretty. I think I'd wear this out. Probably, well, I will not be wearing it out because we're stuck at home. Yeah, I don't know how I feel about this. What do you guys think? Is it okay? Leave your thoughts down below in the comments. Anyways, if you've made it this far, thank you very much. I really appreciated having you, and I hope you guys have a great day. If you like this video, please give it a thumbs up. Subscribe for more cosmology and cosmetology. Thanks, guys. Have a good one.